Hi there, this is Barrett from the C4 Cyber Club at Cypress College. In this video today, I'm going to cover the Security Plus Lab series, Securing Network Administration Principles through Log Analysis. And this is covering the Security Plus objective within the network security domain, and specifically focusing on applying and implementing secure network administration principles. So we will be doing log analysis using some really cool Linux commands like grep and gawk. And we will also be doing log analysis on Windows using the find command, which you'll see is very similar to grep. So on the objectives here, always good to look over this. So what is grep? Stands for Global Regular Expression Print. The grep utility allows you to search through a large number of files and folders for specified text. So very good when you're going through log files and you need to find a very specific area to search for. So you use grep. Similarly with gawk, it will allow you to display output in an easy to display human readable format. So very similar, but you'll see coming up in the lab, there's different use cases for each. The find command on Windows can also be used on Linux, by the way. The find command in Windows will allow you to search for a specific string within a large group of values. So same as grep. So this is the topology that we'll be working with in this lab. If you're following along at home, first thing you're going to want to do is get logged into these machines. I'm already logged in, but we'll be working with the Backtrack 5 internal machine, the Red Hat internal machine, the Backtrack 4 external machine, and also the Windows 2K3 server Windows machine. These two will be in part 3 of the lab. We'll be working on the internal network in parts 1 and 2. The next parts of this lab will just help you if you've forgotten the passwords and login for these specific machines. Great. So at the beginning, we're going to start with using grep on the Backtrack 5 machine. And first things first, we're going to do a little Zenmap or Nmap scan of the Red Hat Linux machine. So what we're going to do, we're going to launch Zenmap from the terminal window, and you'll notice that this actually launches a GUI version. GUI stands for Graphical User Interface. This is basically a front end for Nmap, which is a port scanner. So we're going to use this. You'll see that it already defaults to a specific Nmap scan, and you'll see in the profiles here, if you change this, it changes the different options for Nmap. But for the lab's sake, it wants us to stick with the intent scan. And what we're going to do, we're going to go ahead and target the Red Hat machine. And once again, you can always verify that .147 with the topology, that is the Red Hat Linux machine. And so these options here, what do they mean? So the T4 relates to timing. T5 would be the fastest type of scan. So T4 is a relatively fast scan. T1, of course, would be a very slow scan. And now you might ask, well, why wouldn't you want to just go fast all the time? And well, it depends on what type of system you're scanning. The faster you scan, the more noise you make, and likely you may be picked up by like a intrusion detection system or a firewall. Sometimes if you go slower and they aren't looking for that slower frequency of scan, you might be able to get by that. So you'll come to learn as you use Nmap more and more that it's a very situational, the commands you use are very situational. Now -A, it's often referred to as an aggressive scan. Very fitting for what's set as a intent scan profile. But the -A, it does OS fingerprinting and also looking for versions of services. The -V just stands for verbose, so that's going to display output as it scans. So if you took away that -v, you would just be waiting and waiting until Nmap, or in this case Zenmap, is done, and then it would finally display the results. So -v is definitely useful, something to look at as well. So let's go ahead and hit scan, and we'll give that a second. Okay, so we see that our scan is complete. We have all of this information here. Now, what you're seeing in this window here, this is generally, if you would have ran Nmap in a terminal window, it's very similar to what you would have seen there. You know, it basically looks like the command line. So here's all of the open ports. You see that port 21 for FTP is open. Port 22 for SSH, or secure shell, that is open. And I believe that's something we will be using in the second part of the lab. Port 80, HTTP, that is open, and this is something we're going to be looking at here. Now, instead of this screen, the nice use of Zenmap is that you can come over to the ports and hosts tab, and it gives you a much easier view. So here it's telling you all the open ports, the protocol. In this case, they're all TCP. In the future, you may run across some protocols that are UDP. It gives you the service, so telnets, HTTP, SSH, and since we did that -a, remember, this got us the versions of what it could find, so we know that it's running OpenSSH 4.3, Telnet is BSD derived, the Apache web server is version 2.2.3, etc. So very useful. You're going to come to find that Nmap is one of the most important tools for beginning stages of information gathering and reconnaissance. So, like we mentioned, port 80 is running the Apache web server. So we know that this Linux Red Hat machine is probably pretty much a web server. So what we could do is kind of take a look and see, okay, do they have any kind of like default web page up, or what's going on with this web server? So let's go ahead and in Firefox navigate to the public IP of the Red Hat, or well, in this case it's a private IP on this network. But okay, so we get a Red Hat Enterprise Linux test page. So oftentimes when you see these test pages, it kind of means that it's a default page. It hasn't been configured. Sometimes this is very good to see from an attacker's point of view. So let's go back to terminal. And I believe, yeah, we can go ahead and close out a Zenmap here. Close anyway. Okay, so let's use curl. Curl stands for Client Uniform Resource Locator, and you could actually use this to make a copy of the website. So let's go ahead and curl that address. Okay, and now you see that what it does, it actually prints it out onto the screen. And in Linux terms, this would be, it printed it to standard output. And so what we could do, this is the first case where we're going to use grep. So I'm going to press up to bring that command back again. And now what we're going to do, you saw how if I hit enter right now, it would display this output onto the screen again. But instead, we're going to give the pipe command, and think of it like it's piping this command through a tunnel, and we're going to send that to the grep command. And remember, grep is used for finding particular strings in text or in a file. So we're going to grep for the word test. So it's going to look for anything in this above output with the word test in it. Okay, and we could see that we came across it. This shows you the gathering of the data with the curl command. the average download, what the size of it was, how much was received, and then this is the text that it pulled. So it pulled this little paragraph that you could see includes the word test. So this page is used to test the proper operation of the Apache web server. So now that we've been kind of doing this, like I said, this kind of stuff that we're doing from this machine is considered reconnaissance or information gathering. You're kind of probing a network for information. So if this was a legit attacker trying to find an open port or somehow that they could exploit the system, we're going to move over to the Red Hat system and see how we can capture this kind of activity in a log file. Okay, so at the command line in the Red Hat Linux machine, we're going to change cd, which is change directory. We're going to go over to var log httpd, which this is where the web server logs will reside. And if we did a ls for listing of the files, you'll see various log files here. The one we're going to look at, though, is access logs. So I'm going to type in cat, which is short for concatenate. It's basically a way to display this file onto the screen. Okay, and now you see here there's a lot of information. You definitely don't want to go line by line here. So let's say if you're looking for Nmap scans, how would you find those quickly? So going back to what we just did previously with the grep command, we'll once again cat access log, and instead of printing it out on the screen again, we'll do the pipe command again. So we're going to send this command to the grep command, and then we're going to search for Nmap. Great. Now you see right here, up here, this is the start of the command. So all of these lines after, you'll see each one of them contain Nmap. And you could even, speaking of piping and redirecting, you could even, if I press up again, bring that command back, you could even go further and say, I want to redirect that grep of Nmap into a separate Nmap log. And then if I do ls, this is a little bit extra, not a part of the lab, but I think it's definitely useful. Now you'll see here, there's an Nmap log file. And if I nano to bring up a text editor, Nmap log, you'll see that it pulled only the lines related to Nmap. I'll go ahead and exit out of there. So there's, what else are we going to grep for? Let's see, let's look for Firefox. So once again, a reminder for Linux, super useful. You could press up as many times to pull previous history of commands you typed out. So I'm going to find the one that has grep nmap, and I'm just going to go ahead and change that to Firefox. And there you go. You see all of the lines related to Firefox, which this log occurred when we were on our Backtrack 5 machine and we launched Firefox to visit the site. And then finally, let's go ahead and grep for any kind of curl requests. And you'll find here there are two different logs for that curl attempt that we did. So that's the end of part 1 of the lab, basically going over grep to sort through log files. So next, let's go back to our Backtrack 5 machine and go and clear this screen. Nice tip, Control L is a shortcut for clear. Alternatively, you can type clear, but Control L is also nice, quick clear. So in the second part of the lab, we are going to SSH into the Red Hat machine. So assuming that we know the password for this, which we do, you'll do SSH and the IP address of the Red Hat machine. Once you'll want to say yes here. So it's adding that IP to the list of known hosts for your machine. And the password here is just password. So if you were kind of looking at this in a simulation scenario, let's say somehow we were able to come across this machine's password, then we are finally able to SSH into it, and we want to, as an attacker, we want to create some extra users on that machine and give them passwords so that we can try and sneak back into that machine in the future, and hopefully, they won't notice that there's some new users on there. So let's go ahead and create a group. And you noticed here, when we're on our normal machine shell, we're at root at BT, but notice here we are at root at RHEL, which stands for Red Hat Enterprise Linux. You'll notice the same shell there. So we're adding this group on the Red Hat machine right now, and we're going to add a group Star Wars. And we could verify that all of the groups are located in the file etc group. So if we cat that out onto the screen, you're going to see that this Star Wars group was recently added. And now we want to add some users to that. So we'll do user add Luke, and we'll add him to the group by adding the -G option. We're going to add him to Star Wars. We're going to also add Vader. Whoops. Add him also to the group Star Wars. And we will add Yoda for backup. Add him to Star Wars also. So let's give Luke a password. Now, full disclaimer, these passwords that we're adding in this lab are not recommended in real life. Obviously, just making it easy for a quick example purpose. And you'll notice that as we add, the lab has us add the word son as the password, it's actually going to yell at us and say, that's a bad password, it's way too short, but we can just go ahead and continue to use it for now. Now we'll add password for Vader. That's going to be dad. I'm going to retype it. Okay. You'll see here all authentication tokens updated successfully. And one more password for Yoda. And that's going to be green. Great. And we could actually even verify that those users were added and added to the groups by catting etc password, which is where all of the user list is located. So you'll see Luke, Vader, and Yoda have all been added there. And so this first number here is the UID or user ID. So you'll see they have 501, 502, 503. And the second number is the group ID, which you'll see that they're all 501. And if we catted out the group again, you notice that the Star Wars group is 501. So that all makes sense. So let's go ahead and take a look at the logs that this created, or what it created within the logs, I should say. So we'll go back to the Red Hat machine. We're going to go to cd, change directory once again, to var log. I'll do an ls for list files. You can see there's also a good number of logs here, but we're going to be looking at the secure log. This is related to SSH logins. So we're going to do cat secure. Once again, you see quite a lot of information here. So let's go ahead and use grep again in this case. We'll do cat secure pipe grep. And since we're going to use two words, we're going to use a string called new user. We want to put it in quotes. So we're looking for everything that's in between these quotes. So we're looking for the string new user. And you'll see, as expected, there are 3 lines here. So we have new user for Luke, Vader, and Yoda. Now we're going to go over the Gawk command. It's a bit different than grep. So best way to look at it is to check out this string here, or this line. What it does, it breaks up every space in the line becomes a delimiter. And then it basically creates numbers for each section. So you'll see May is number 1, 28 is 2, all of this timestamp area is 3, the RHEL is 4, this entire user add and number, even the colon there is, what am I at here, 5. So then you have the values for new and user and name are 6, 7, and 8. So what we do with a command like this is we're saying, okay, let's run Gawk and print out only section 6, 7, and 8 and reference the file secure. And then on top of that, pipe that information into grep and search for new user. So let's go ahead and do that now that we've kind of walked through what that does. Okay. And the syntax here is very important. So you want to make sure that you get the apostrophes, the curly brackets, the $sign before the numbers, which basically is denotes that this is a variable. Okay, secure, and then grep for new user. There you go. So now you could see how Gawk allows you to become much more specific about the information you pull back, especially when you have such a long line from a log file such as this. So you're getting only new user name and then Luke, Vader, Yoda. Now, just as a quick example, what happens if I took out the grep from this command? So we're just only running the Gawk command here. Well, so what you see here is that it ran the Gawk command looking for section 6, 7, and 8 on every line of the log file. So once again, that's why you take that command and then you send it into grep and you're searching for a new user. And then you're only getting those 3 lines. So essentially, the real strength here comes in kind of combining these tools together. And the more you use them, the more you get in situations where you're like, oh, hey, this would be really useful. So definitely really big tools to get the hang of. Great. So now in the third part of the lab, we're going to be moving on to the external network. And we're going to have a little fun with password cracking. So let's go to our Backtrack 4 machine. We're going to open terminal. So in the terminal window, we're going to go ahead and run xhydra. And much like when we ran Zenmap, you're going to find that this opens up a front-end GUI for Hydra. So what we're going to want to do is add the IP address of the Windows 2K3 server into single target. So we're going to do 10.10.19.202. We're going to change the protocol here to FTP. Very important. Once we come to passwords, we're going to change the username to administrator. And for password list, because we're going to do a dictionary attack, so we're basically referencing a big list of files. We're going to choose from the root directory, we're going to choose this wordlist.txt. And that is pretty much it. We're going to come to start. And let's go ahead and start that up. It's going to take probably a good few minutes to 5 minutes. While that's running, I could actually even show you what that word list looks like. So if we come to, yeah, it's right here. So this word list is what Hydra is going through right now. And it's basically just going to try every single one of these until it gets a successful response. Okay, so let's come over to our Windows 2K3 server. While that runs in the background, we'll kind of get head over to the log file area here. So now we're on a Windows machine. And we're going to move to CD, C drive Windows, System 32, log files, MS FTP SVC1. Okay, DRR. So you see we have a very recent log file that's dated today. Let's take a look at that real quick. So we could do type, which is much similar to cat on Linux. I'm going to do x200630.log. All right, and you can see there is a lot of information in here. So once again, we're going to be doing something very similar to grep. You'll see here we're going to be using the find command. And we're specifically looking for a code of 230, which would mean a successful login attempt. So you could see here, this looks like it's still going. It's done about 14,000 tries so far. Let's go ahead and we could see if one's been successful so far. So I'm going to press up and we're going to pipe once again and do find 230. Let's see if we've made a successful attempt yet. Okay, so I actually ended up coming back over to the Hydra window because it did take a little bit longer than I thought it would, but it took about 5 minutes. So just give it some time, let it run through, and you'll see here it gave multiple reports, and it ended up with over 165,000 tries. But we did eventually settle on the password, which was just simply password. So let's come back over to the Windows machine. And now, once we type out the log file, grep it into find, and once again we're searching for 230 because 230 means that the password was correct. It was a successful login attempt. Let's go ahead and see if we find that now. And there we have it. And for some reason, there's actually 2 listings in here, which is kind of odd. But so you see it has a timestamp. It has the IP address. So if we double check, we see that .148 is this backtrack 4 machine. And it has a 230 successful login attempt. So this demonstrates how to check Windows FTP logs. Earlier we went over checking web server logs on a Linux machine and also going through SSH logs through the secure log file. So this concludes this lab, part of the Security Plus lab series on securing network administration principles through log analysis. Thanks a lot for watching, and feel free to leave any questions or comments or suggestions in the YouTube comments below. Thanks.